Hi all, welcome back to my channel. So in today's video we are going to talk about FSM, which is finite state machines. So finite state machines play an important role in Verilog because when we learn about when we are writing codes in Verilog for something like traffic light signal, or when we are learning some protocols like APB protocol and all, you will come across this FSM concepts. So I don't want to miss this FSM while I'm explaining about Verilog codes. That is why I have taken this FSM with you. But in today's video, I'm not going to explain in deep about what is FSM and all, because if you are familiar with digital electronics, then you will know what is this FSM and what are kinds of FSM you are having and what is differences and everything you know about it. So I don't want to explain much about it. But what I'm going to explain in today's video is we are going to write a code for this FSM in Verilog. Okay, in order to write a code, you should have a state diagram and state table for that. So that is why what we are going to do is we will be taking a sequence as an example and we'll be drawing the state diagram and state table for it, and then for that particular code only we will be going to write a code for that particular sequence only we will be writing a code in Verilog. Okay, so that is what this session is about. So, coming to FSM, before going into all these things, let us first have a brief discussion on what is FSM. This is for those who don't know about FSM and all. Okay, I just want to give you a brief example on this FSM. Okay, if you already know about FSM and everything, you can skip this part. Okay, before going into the topic, if you are someone new to this channel, consider subscribing this channel and hit on the notification bell also. Also follow me on all social media handles. Also I have a Telegram channel where I'll be uploading some questions or assignment types. Okay, and you can also ask doubts about this any concepts in that particular channel. Okay, you can I'll be leaving the link is in my description box. You can go and join there, right? So coming to FSMs, finite state machines. So we will use this finite state machines in many places, like many programmers or many mathematicians and many professional fields also use this FSM. So what is this FSM? What does it do? So basically FSM is used in order to describe any system or any design which is having some limited conditional states. Okay, that means whenever any system that you are having is having any limited conditional states, then okay, then we'll be using FSM at such points. So let me give you a small example for this so that you'll easily understand about what is FSM. Let us consider that we are designing a cleaning robot. Okay, so when it comes to robot which is designed for cleaning purpose, it will be working under certain states, is it or not? For example, its first state will be ideal, and then the robot should move. Yes, and then it should clean, and then it should mop. Okay, and there may be certain obstructions while it is moving or else like that. So at such cases it should decide what it should do, like it should move to left or it should move to right. So in this way it is having some limited conditions. Okay, so we will be using FSM in order to create these conditions. Okay, that means when your robot, for example, is in ideal state and it should change from ideal state to some moving state, and from moving state it should move to some mopping state. So in this way, in order to change from one state to another state, it needs certain conditions. Is it or not? That means it won't move until and unless we are giving some order or we are giving some condition for it, right? So this conditions is nothing but FSM. So we can simply call FSM as it's like some set of rules. Okay, some set of rules which make the robot to decide which work to do or from which state it should go to another state. Okay, so all this come under FSMs, right? Hope you are clear about this FSM. Okay, so just like as I said, it is just a set of rules or conditions which makes the design that you are designing to work. Okay, so this is about FSM. So in Verilog, FSMs are widely used to create and control the systems. Okay, in order to control any system or in order to model any system with certain limited conditions, we will be using this FSMs. As I told you in the starting itself, we'll be using it in many protocols or many user interfaces, or in as this example while we are designing any robotic systems. So in all these things we will be using this finite state machines. Okay, so they provide the structure and systematic approach for your design. Okay, so whatever you're designing, it will be creating the structural and systematic approach so that everyone can easily understand. Because whatever ultimately whatever design you are going to design, or whatever circuit or something you are creating, it should be for the use, or else is it or not, it should be for the real time usage. So every when the particular design, or when the particular for example this cleaning robot, when it will get succeed only if everyone can understand it easily. So your FSMs will be making that process easy. Okay, in order to analyze any design, or in order to structure any design in a particular systematic way, FSMs are very useful, right? Hope you got a clear idea on what is FSM, right? So as I told you, so this is some protocol, like this is a APB protocol if you see here. Okay, so in this APB protocol I'm just giving a basic idea. Okay, while I'm explaining about these protocols, I'll be explaining clearly about what is this FSM and all. But in this way the conditions will be, see, presently the see is in the protocol, the transfer is in ideal state, and only when the selection is 0 and t enable is 0 only, then the transfer will be taking place. Then it will be going to the next state called setup state. So it is having three states: ideal, setup and access. Okay, so based on selection and enable input, the states will be changing from one state to another. Like it will be changing from ideal to setup, and from setup to access. Again from access also it will move to either period E or else anything. So based on the states, based on the sequence that you are giving, it will be moving from one state to another state. So these are called conditions. Okay, so hope you got an idea of what is this. So, as I told you in the starting, what we are going to do here, we are going to write a Verilog code for FSM. Okay, so for this, what we are going to do, we are going to take a sequence. Okay, let us take the sequence 1010. Okay, so this is my sequence. So before going into drawing a state table and state diagram for this sequence, firstly, as I think you already know about this, so FSM is categorized into two parts, which is Mealy and Murray. Okay, so based on the usage of, you can draw the state diagram or you can write the state table in any of these two FSMs, like in any of these state machines, like Mealy state machine or Murray state machine. It's your wish. Again in Mealy and Murray also, they are having again two types, like overlapping and non-overlapping. Okay, so overlapping states and non-overlapping states, you will be seeing what is this overlapping and what is this non-overlapping state, right? So today what we are going to see is, we are going to draw a state diagram for this sequence 1010 in Mealy state machine. Okay, so we'll be using this Mealy state in order to detect this sequence 1010. So since it is Mealy, you already know the difference between Mealy and Murray. Okay, if you don't know about the difference between Mealy and Murray state machines, okay, you can ping me so that I'll explain that clearly. But as for now, I don't want to explain about the differences and all, because as I told you, I don't want to give in deep concept about this FSMs, because what we are trying to achieve is, we are going to write a Verilog code by using this FSM. So in order to write the Verilog code, you should know about the state diagram and state table. So that is why I am explaining the state diagram and state table before writing a code for this particular FSM. Okay, so this is my sequence. So 1010. So it consists of 4 bits. since this is the Mealy state machine. So how many bits that are present, those many states only will be present. So since 4 bits, you will be having 4 states. Okay, let us consider those 4 states as A, B, C and D. Okay, so these are the 4 states. Since 4 bits, 4 states. So presently it is an ideal state. Okay, as soon as you give reset, then it will be everything will be set to the default values and all. Now coming to the sequence. So whenever the A value, okay, A state receives 1. Okay, that means here 1, right? The first bit is 1. So whenever the A receives 1 bit, okay, then it will be moving to the next state B. Clear? Yes, so we are mentioning it as A. 1 by 0. What is this 0? So this is input. Okay, this is output. Why input is 1? Because only when input is 1, it will be A will be moved to B. If input is not 1, then A won't be moved to B, because that is the sequence condition that we are getting. 1 0 1 0 is your sequence. So in order to move your sequence, the A bit should be 1. Okay. So when A receives 1 bit, then it will be moving to B. But 1 is not the only output here, as until 1010 sequence is detected, the output won't be activated. So that is why the output is 0. Right? Clear? Yes. Now what happens? B has received 1. Now, until B receives 0, it won't be going to C. So that means B value, whenever B value is 0, when B receives 0 bit, then it will be going to C. Similarly, when C receives 1, it will be going to D. Just like that, when D receives 0, then the output will be activated. Clear? Okay, hope this is clear, right? I'm explaining it one more time. So when A receives 1 bit, okay, then it will be moving to B. And when B receives 0, because after 1 it is 0, so when B receives 0, it will be moving to C state. And when C receives 1, it will be moving to D state. And when D receives 0, then the output will be activated, like the output will be 1 until the last state is 0, the output won't be 1. Clear? Yes. So this is all true cases. That means when A receives 1, then it will be moving to B. When B receives 0, going to C. When C receives 1, going to D. So this is all the case that when your sequence is just 1010. Okay, you have designed the state machine for 1010, and the input that you are giving is 1010. Okay, so all true cases you are giving for this sequence, so it is fine. Now for example, if you are giving 0101 as your sequence, okay, so what happens? That means you have given all the false cases. Now what happens? Okay, that means when A receives 1, it will be going to B. If not, that means when A doesn't receive 1, because it may be either true or false. So when A receives 0, then what happens? If A is 0, then it will be staying in that particular state itself. Okay, that means it will be in A only. So that means when A receives 0, that means when A is 0, it will be staying in that particular place. Clear? And when A is 1, it will be going to B. Now similarly changing to, going to in the sense it will be changing from one state to another, then the A value is changed to state B. Okay, now coming to B, right? When B receives 0, okay, it will be going to C, or it will be changing to C. But if A receives 1, then what happens? If B receives 1, then it will be staying in that particular state. Okay, that means if it is 1 by 0, then it will be staying in that particular case itself. Now if you see here, if here A value is 0 and when B is 1, then it will be it will be staying in that particular place. Now coming to C. Now if C is 1, then it is going to D. If C is 0, then what happens? If C is 0, it will be going to the state where 0 is present. Where is the state with 0? Here A is the state which is the 0th position. So then it will be going to A. Okay, when this happens, when C is 0. Okay, that is when input of C is 0. Okay, now coming to D. Okay, when D is 0, it will be giving the output 1 and it will be going to the home place. When it will be going to the home place and all, we'll be seeing that. But as for now, just take it like this. Okay, when D is 0, then the output will be activated. Like the output will be because it has received the entire sequence, because here the sequence is 1 and here the sequence is 1 0 and here the sequence is 1 0 1, here the sequence is 1 0 1 0. So it has the entire sequence that we are designing. So that is why it has activated the output as 1. Fine. If D is not 0, that means if D is 1, then what happens? Then it will be going to the place, or it will be going to the state which has 1. Now if you see here, what is the state that is having 1? B. So it will be going to D. Okay, when D is 1, and here the output is 0, because here if you see, if you are getting 1 0 1 1, that means here you should get 0 in order to complete the sequence. But if you are getting 1, means the sequence is broken here. Okay, so since it is broken, it will be going to the previous where the particular one state is there and the output is still 0. Okay, again from here the sequence will be starting. Clear? So this is how the sequence is. This is the state diagram of Mealy state. Now coming to D. Okay, here as I told you, if D is 0, then it will be giving the output 1. Then what next? Okay, then again it should start another sequence. Is it or not? Okay, only this won't be your sequence. Is it or not? So your sequence will be like this. For example, in this way, it is in a continuous manner. So now what happens after completion of one sequence? It should go somewhere, or it should start somewhere. Okay, in at this point of time you will be seeing the difference between overlapping and non-overlapping cases, because in overlapping case what happens means, okay, in overlapping case, based on the previous state, okay, based on the previous values, it will be going to the states, whereas for non-overlapping case it will be going to the home state, like A. Again it will be starting from A. Okay, here this is 0 by 1. This happens when only when it is non-overlapping. Okay, only when it is non-overlapping, then again after the entire sequence of 4 bits is detected, again it will be starting for the next 4 bits. That means after this is selected, again these 4 bits need to be taken care of. So for these 4 bits, what it will take, again it will start from A, and again the sequence will be like 0 1 1 1 0. So this sequence will be detected. Okay, but when this is a overlapping sequence, what happens means, for example, you are taking like this, okay, some 1110. So this is your sequence. Okay, this sequence is detected. Fine. So 1010. Now what happens after detecting 1010? So for the overlapping sequence, what happens means, it will be checking the previous bits. Like if you see here, 1010, this is my sequence, one sequence, it is fine. And if you see here, this is my second sequence, okay, 1010. So what happens, it will be taking, or else if you see here, this is starting from here, if the next sequence is starting from here, then it will be checking the previous states where the sequence will be starting. Like since it is 10 starting, it will be taking from here. Okay, so then what happens, the D will be going to the previous state where the 10 place is there. Like here if you see, from here it will be going to B for overlapping cases. Okay, hope you are clear about this. Okay, if you have any doubts you can ask me, right? So for this state diagram we are going to create a state table, right? So this is the state diagram. Okay, for this state diagram we are going to write a state table. So based on this state table only we are going to write a code for FSM. That is why state table is important. So you all know how to create the state table, like you will be seeing present state, next state, and you can also create for output also, right? So what are the states, present states? I have taken A, B, C, D. Any names you can take. It's not only A, B, C, D, anything you like. So these are the present states. Now in order to move to next state, it should depend on input. Is it or not? The based on the input value, whether it is 0 or 1, based on the dependence of that only, it will be moving to the next state. So based on the x value, like if x is 0 and if x is 1, so if x is taken as input, like if you are taking this as x, then based on if it is 0 or 1, the state will be taking place. So if it is 0, what happens? It will be in A only, so the next state will also be A. Now if it is 1, it will be going to B. Okay, similarly for B, if it is 1, it is staying at B, and if it is 0, it is going to C. Okay, similarly for C, if it is 1, it is going to D. Okay, and similarly if it is 0, okay, it is going to A. Okay, and here at D, what is happening? If this is like 0, yes, if this is 0, then it is going to, if it is non-overlapping case, then if it is 0, then it is going to the original state A. Okay, home state. Okay, and if it is not 0, that means if it is 1, then it is going to B state. Okay, so and coming to output also for x equal to 0, x equal to 1, because here if x equal to 0, there is change in output, so that is why. But if you see here, all the outputs are 0 only, so all the outputs are 0. When the output will be 1? When x equal to 0. So when x equal to 0, the output will be 1, or else the output will be 1. Okay, or else the output is 0. Clear? So this is how you will be creating the state table for this particular Mealy state. Clear? So hope you are clear about this particular FSM. Okay, if you are still having any doubts, okay, you can ask me. And here if it is for example, if this is for non-overlapping, the state table is like that. For example, if this is overlapping state, what happens? Everything will be same almost. Okay, but where the difference will be, here in the D state, if x equal to 0, it is moving to x equal to 0, it is moving to C. Okay, and then it is going to, or else if x equal to 1, then again it is moving to B. Clear? Hope this is clear for you. Okay, if you're still having any doubts, you can ping me in the comment box. Also, in tomorrow's session, we are going to see how we will be writing the code for this particular FSM by using this state table. Right? So this is all for today. Thank you. And once again, please subscribe to my channel if you didn't already. Bye.